This video will walk you through a biobricking method we call amplified insert assembly. This method has many advantages over other methods of DNA assembly, including no need for gel electrophoresis, no custom oligos, high numbers of colonies using homemade competent cells, no need for multiple antibiotic resistances, and the ability to work with small parts. But the most important reason to use this method is its high fidelity. In our experimental results, up to 99% of resulting colonies end up being correct. To perform AI assembly, you will need 4 to 6 hours. However, the actual time spent at the bench will be significantly less, allowing you to do many other things during your workday. Now on to the method. The first thing we need to do, of course, is mini prep our cultures to obtain plasmids containing the two parts we want to assemble. We'll call them plasmid A and plasmid B, each containing part A and B respectively. These plasmids have the standard BioBrick format using EcoR1, XBA1, SPE1, and PST1, abbreviated here as EX, S, and P. This mini prep will take approximately 30 minutes. We need to decide which one of these parts we want to be our vector and which is going to be the insert. There's an advantage to making the smaller part the insert because we're going to be PCR amplifying the insert part, and using the small part will make that step go faster. But you can make this choice based on whatever criteria you deem appropriate. In this case, part B will be our insert. So after the mini prep, we're going to perform PCR amplification of part B. We'll want to use a high-fidelity polymerase like Vent or PFU Turbo, but you can use any high-fidelity polymerase that meets your desired specifications. For this amplification, we use standard primers that anneal approximately 150 base pairs outside of our restriction sites on all our BioBrick plasmids. This is important because it allows us to column purify the PCR products of even very small parts like ribosome binding sites. These are the primers that we use for colony PCR, and if you're using the PSB series of plasmids from the parts registry, then you can use primers VF2 and VR. We're also going to run this PCR for only 25 to 30 cycles to ensure that our polymerase doesn't get burnt out and start making errors. This PCR should take 1 to 2 hours depending on the thermocycler, which polymerase is used, and the size of the part being amplified. While our PCR is running, we're going to start our vector digest. We're going to spec the concentration of our mini prep so that we can add a 1/4 picomole of plasmid to our digest. For our mini preps, this is usually around 10 microliters. We'll now digest our vector with 2 end restriction sites, in this case SPE1 and PST1. Then we'll incubate this digest until the insert PCR is finished cycling. Once the PCR is finished, we'll purify the PCR product using a spin column, spec the concentration, and then digest a 1/2 picomole of purified product with enzymes complementary to our vector digest, which in this case will be XBA1 and PST1. To this insert digest, we'll also add DPN1 restriction endonuclease. This will digest away all the template plasmid used for our PCR. The insert digest will proceed for 1 hour, and during this time we'll add Antarctic phosphatase to our vector digest. Phosphatase eliminates vector background by removing the terminal phosphates from the cleaved ends, thus preventing the vector from self-ligating. Once that hour is up, we'll place both vector and insert digest in an 80-degree bath for 20 minutes to denature all the enzymes and stop all the reactions. At this point we have an open vector containing part A and a digested insert containing part B. Backroom from part A has been removed by Antarctic phosphatase, and backroom from part B has been removed by DPN1 digestion. Next, we'll ligate the insert and vector together using T4 ligase. The molar ratio we're shooting for here is 4 moles of insert per mole of vector. Because we digested twice as many moles of insert, this means that the volumetric ratio is 2 microliters of insert per microliter of vector. Performing the entire ligation will take approximately 30 minutes, and then you can transform using an electroporator, heat shock transformation, or whatever works for you. After transformation, we'll let those cells recover for an hour and then plate on an antibiotic corresponding to our vector plasmid. We get about 99% of correct colonies, so we'll just pick one of them the next day, culture it, and sequence it. In a nutshell, that's amplified insert assembly. We've had really good results with it, and we hope it works for you too.